Welcome to another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. You can also find us on iTunes as well as an RSS feed and get the entire back catalog there. I also have here Jeff Squyres from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks again for your time.
Hey Brock, it's middle of the summer, school's out. You're just, I imagine, slacking off for the entire summer, right? I mean, that's what all you academic researchers do during the summer. Am I right?
I'm actually trying to replace our entire cluster by sometime next year, so I got a big project coming up.
Oh, so you're working hard.
Oh,
no rest for the wicked. How terrible.
No vacation for me.
Right.
Okay.
What other deadlines we got coming up? There's a supercomputing BOF deadline is coming up, end of July, I think?
Yeah, I think there's a couple of supercomputing things, but I don't think there's really anything else that I'm aware of coming up, so I think that's the only one. Okay.
All right, well, what do we got today?
Okay, so today we are going to be covering Shifter. This is a often requested topic, and we finally got a hold of some people. So we have with us Shane and Doug. Shane, Doug, why don't you take an opportunity to introduce yourselves?
All right. Hey, I'm Shane Cannon. So I'm a member here at NERSC at Lawrence Berkeley National Lab. My educational background is in physics, so I've got a PhD in physics from Duke, but all my professional career has been in high performance computing and technical computing. For everything from system administration to being a group lead at Oak Ridge and a group lead here at NERSC. And right now, I'm in the data analytics and services group, where I work on trying to help users use our systems more effectively, especially on the data side. And then I'm also a member of a project called Keybase, which is a genomics platform that we're trying to build up.
And hi, I'm Doug Jacobson. I also work at NERSC at the Lawrence Berkeley National Lab. My educational background is in bioinformatics at the University of Michigan, but I've spent my entire professional career here at NERSC, ranging from user services to systems administration and system software engineering, which is where the Shifter project really comes in.
Yeah.
Okay, so what is Shifter?
Maybe I'll start off and Doug can chime in. It's maybe useful just to think about why we invented this. What we wanted to do is we've got a growing number of users that are trying to use systems like Cray, which is our Cray system, to do a broader set of things than just modeling and simulation, sort of the traditional HPC workload. So we want to enable more users to use the systems more easily. And we saw containers, Docker containers, as an interesting way to kind of open that door. But you couldn't really run Docker on our system. So Shifter was really a response to that problem and trying to think through the issues with Docker, but still trying to enable as much of that capability on our systems. So what it does is it allows you to run containers on our systems and other HPC systems at scale, securely, without some of the side effects of Docker. Anything to add, Doug?
Yeah, so this has also been not a recent sort of investigation for NERSC. I mean, NERSC has been in our capability machines, so things like our traditional cluster systems. We've been doing forms of virtualization for quite a long time, starting with Shane's CHOS project. And so really, we've been dabbling in this kind of thing since 2005.
Yeah, for a decade or over a decade.
Yeah. But Shifter is just the latest sort of incarnation of that. But it's the first one that allows the user to directly control the every aspect of the environment. Now, I would like to clarify, though, that Shifter is not actually a container system. It's a container compatibility system.
Yeah.
We don't do anything. A container would imply both sort of the operating environment, which is really what Shifter is thinking about, but it also thinks about resource limitations, and that's really the job of the resource manager. And so, actually, one of the design principles of Shifter is that it does not at all try to do resource limitations. It leaves that to, in our case, it's Slurm. That's our workload manager. But so we really don't do a whole lot with C groups with Shifter, and that's by design.
Yeah.
All right, so Shane, let me zoom in on something you just said there that was kind of interesting. So this is not Shifter is not a container system in itself, and it's in addition to Docker. But you made this interesting comment that you can't run Docker on your systems. Could you give a little insight into why and what some of the problems are?
Yeah, sure. And it's kind of multifaceted. So probably the biggest reason is sort of security concerns. So if you try to run stock Docker, if anybody's played around with Docker and sort of tried to do this, you can, once you sort of allow a user to use Docker, then you've kind of given them the keys to the kingdom on that node or that system, right? And so since we want to allow users to use Docker images, but also be able to access things like shared file systems, it really would be a non-starter for us to just put Docker in unaltered and just open it up for users to run containers. There's also other problems with, in a kind of HPC environment that we're running on the Crays, there's no local disk. Docker, you can work around this, but Docker really assumes local disk, and that would be problematic. We really want to make sure that the solution that we put forward can scale to the full size of our systems, and so there's constraints around that. And then we also wanted to make sure that we could allow we could run it on systems maybe that didn't have the most modern kernels on them. So some of the systems can be a little, you guys know, the kernels can sometimes lag in the HPC space, and we didn't want to have this dependency like you had to be running the latest version of the kernel to be able to use the system.
So, you just told us what Shifter is. I mean, why containers in the first place? Why is this a useful technology for science?
Yeah, and I think this is good because this is something we're really excited about. So first and foremost, I think what's interesting about containers is they really give you a framework for enabling reproducible science. So, one of the challenges in technical computing is you're running your application, but things are changing out from underneath you a lot of times as the systems are upgraded or modified or changed. With a Docker container, especially if you have a Docker file that you're using to build that image up, you've got this auditable recipe of like, this is how I created that, right? So one, you've got something that's auditable. Two, once you've built it and you've registered in, say, a dockerhub, now you've got something that you can always go and pull back down. Others can pull that down and reuse that same image. So you really start to make it easy for someone that you can say, here's the analysis I did, and that this other user from the community can go pull that image down and run the exact same thing that you did. And then, and also you can do that too. So a month later, a year later, if you want to go back and reproduce those results, you just pull that image down and do that. So I think this is really powerful, and this is why I think it's going to be, it's going to grow in adoption within the scientific community as more and more people understand what this enables.
So where does the name Shifter come from?
I'll let Doug tell you because he came up. We were like, what name should we call it? And
so actually, we had tried a lot of different things, and one of basically, I think that Shane originally posited that we should call it Proteus, which is a shape-shifting.
Yeah, or something. I was thinking of some mythology kind of thing or something like that.
And I was having a difficult time moving off from that, and so I decided to just sort of latch onto the shape-shifting aspect of it, and that's really where Shifter comes from.
Yeah, and so we talk about like sort of shifting into an image or an environment, and so that's sort of the idea there.
So of course the big question for all these container-ish type systems, whether they're relying on one or implementing their own, is do you require root permissions to set this up or use it?
Yeah, so so the short answer is yes, we do. So what we do with Shifter, and I should make this clear that these were very conscious decisions we made along the way. We tried a lot of different things. As Doug mentioned, we've been doing this for.
Can we back up for a second and restart the question? Because I think what I'd like, can we clarify the question? Are you talking about, does the user need root privilege to introduce a container onto the system? Or do you need root privilege
to install the software,
to set it up, or to install the software? Or let's just clarify what you're.
Yeah.
Sorry.
Actually, I was asking both.
Okay. All right. So. Okay. So yeah, Shifter does require some level of root privileges. So the short answer is yes. we went through a lot of different iterations when we were developing Shifter, because like Doug mentioned, we've been sort of doing this for almost a decade now. So let me explain where we need privileges.